In this video, we'll take a look at the quadratic formula. So the quadratic formula is used to find solutions to quadratic equations. So first you'll see on the screen here that I have a quadratic equation. Quadratic equations are equations in which the highest power of the variable is a 2. And we can see that right there. And we also have an x to the 1, but that is not mandatory. But as long as you have highest power of a 2, then you are dealing with a quadratic equation. Now this is the general form of a quadratic equation. ax squared plus bx plus c equals 0. So you'll notice the a, b, and c, they are values that we refer to as the a and the b are coefficients of x squared and x, respectively. C doesn't have an x that it's multiplied by, it is a constant. So when we come across a quadratic equation and we want to find the values of x that make this equation true, we must put the equation into this general form. And when we do, then we can use the quadratic formula, which you can see below. X equals negative b plus or minus. Notice the plus or minus. So this will produce two different answers. Plus or minus the square root of the quantity b squared minus 4ac, and that whole numerator over 2 times a. So before you use the quadratic formula, make sure that your equation is in the general form, and then you can see what your values are for a, b, and c. So let's practice. I've got an equation. Here, find the values of x that satisfy this quadratic equation. X squared minus 7x plus 10 equals 0. So notice that the values for a, b, and c, this is in general form, so the values for a, b, and c are 1, negative 7, and 10, respectively. So let's solve for x. X equals, again, let's look at that formula, negative b plus or minus the square root of b squared minus 4ac, and this is all over 2a. So I'm going to start subbing in the values. X equals the negative of b. So we have negative 7. Let's write that first, okay? Sometimes it's not necessary. I might just go ahead and change that to a positive, but I just want to really be clear that the negative is in the formula. B is negative 7. Plus or minus the square root of b squared. So b is negative 7. We need to square that. Subtract 4 times 1 times 10. And put that all over 2 times a, which is 1. Okay, a little more simplification. Actually, I'm going to move over to the right here. So negative 7. That is 7. Plus or minus, what's in the square root sign? Well, negative 7 squared is 49. And we will subtract 40 from that. Okay? And it's all over 2. That's starting to look better already. We will move over, go one step further. 7 plus or minus the square root of 9 all over 2. And actually, let's go one step further. 7 plus or minus 3 over 2. Okay, you see I've carried on that plus or minus. The plus or minus in this formula means that this will produce two answers. X equals 7 plus or minus 3 over 2. So now we should really split those, okay? So for the first answer, it will be equal to 7 plus 3 over 2, or x equals 7 minus 3 over 2. X equals 10 over 2, x equals 5, or x equals 4 over 2, x equals 2. So we have our two solutions to this quadratic equation. That means if I sub in a 5 to that original equation, it will be true. And if I sub in a 2 to the original equation, it will be 2. Let's take a look at a second one, and I'm going to ask you to write down the equation, pause the video, and see if you can solve it. First, I will give you the quadratic formula. X equals minus b plus or minus the square root b squared minus 4ac all over 2a. All right, so there it is. Pause the video and find the two solutions for this quadratic equation. Okay, I'm going to go ahead and find x. I noticed that my quadratic equation is already in general form. It's got my x squared term first, plus my x to the 1 term, plus my constant equals 0. So we are ready to go. X equals minus b. Actually, you know what? Let's state what a, b, and c are first. All right, so a is equal to 1. B is equal to 5. And C is equal to negative 24. All right. Probably a good idea to write them out, and that way we do get that reminder of the negative and the 24 and so on. So X is equal to negative B, that'll be negative 5, plus or minus the square root of 5 squared minus 4 times 1 times negative 24, all over 2a, which is 2 times 1. X equals negative 5 plus or minus the square root of 25. And now I've got here negative 4 times 1 times negative 24. So 96, that'll be positive because we have a negative times a negative. We will put this all over 2. X equals negative 5 plus or minus the square root of, well, 96 plus 25, 121, all over 2. Now, I can see that 121, if I square root it, it is a perfect square, right? It's 11. If it wasn't, it probably would be best to leave it in this radical form and start with separating the plus and minus. Since it is a perfect square, then I will do x equals negative 5 plus or minus 11 over 2. And now I can't do any more, so I must start to find the two possible values. X equals negative 5 plus 11 over 2, or x equals negative 5 minus 11 over 2. X equals, so negative 5 plus 11, that'll be a 6 over 2. X equals 3. Or x equals negative 16 over 2. X equals negative 8. 3 and negative 8 will be your answers. You can always check them by taking them, putting them back into the original, and see that the equation holds true. All right, well, let's take a look at yet another example. And I'm actually going to suggest that you pause the video and try this for yourself first, and then watch my solution to see that you got the right answer. And if not, maybe you will see where you went wrong. All right, so x equals minus b minus 4. And plus or minus the square root of b squared minus 4 times 2 times minus 6 all over 2a, which is 2 times 2. X equals 4 plus or minus the square root of 16. I have a negative 4 times 2 times negative 6. So this is going to be a positive. And 4 times 2, which is 8, times 6 is 48. All over 4. Okay, keep going. X equals 4 plus or minus the square root. 48 plus 16 is 64. Another perfect square. Okay, and this is over 4. And so let's move on up here. As another reminder, if this is not a perfect square, then leave it in radical form and continue with the plus minus and go into decimals. Okay, we're not seeing that happen right here. So x equals 4 plus or minus 8 over 4. Now I will split. X equals 4 plus 8 over 4, and x equals 4 minus 8 over 4. Okay, x equals 12 over 4, so x equals 3, and x equals negative 4 over 4, x equals negative 1. I do encourage you to sub those values both into the original equation and see that it holds true. In fact, let's do one in our head right now. We'll sub in the 3, okay? 3 squared is 9. 9 times 2 is 18. We will subtract 4 times 3, so 18 subtract 12 is 6. Subtract 6 is 0. That one works. Okay, that's what I mean, sub in. Okay, and lastly, we have somewhat of an application question for the quadratic formula. A rectangle has the dimensions of 8 meters by 12 meters, and therefore has an area of 96 square meters. Find the value of x that when added to both dimensions, the area will be increased by 57 square meters. So you'll notice I wrote down an area formula here for the original rectangle. 8 by 12 is 96. Now what we're asking is, if we increase the 8 by an amount and we increase the 12 by the same amount, then the area will be increased by 57. So take a look at that second equation. X plus 8 is the one dimension increased by x, and 12 plus x, did I say x plus 8? 8 plus x and 12 plus x. When those two are multiplied together, they would give an area of 96 increased by 57, which is 96 plus 57. Now, we want to find the value of x that makes these true. So let's continue to turn this into a quadratic equation, which means we will multiply these two binomials together. All right, so remember FOIL? First outside, inside last. So 8 times 12, 96. 8 times x plus 8x. X times 12 plus 12x plus x times x plus x squared equals 96 plus 57, which is 153. It's looking a little bit like a quadratic equation because we have highest power of 2 on the x. So let's just sort of put it into the form ax squared plus bx plus c equals 0. We just need to do some rearranging. First, I have a couple of like terms, 8x and 12x. So that will be, let's do 96 plus 20x plus x squared. I'm going to move that 153 to the other side of the equal sign, minus 153, so that it equals 0, aiming for this general form, okay? Putting this in a different order, let's put the x squared term first. We'll put the x to the 1 term second. And the constant 96 subtract 153 minus 57 equals 0. Okay, this is in general form. I want to find the values of x that satisfy this equation. Okay, I will do the quadratic equation, or quadratic formula actually, in green now. So x equals let's write a equals 1, b equals 20, c equals minus 57. All right, so minus 20 plus or minus the square root 20 squared minus 4 times 1 times minus 57. All over 2 times 1. X equals minus 20 plus or minus the square root. All right, so 400. Negative 4 times 1 times negative 57. I know it's going to be a positive. And 4 times 57. That's 228. All over 2. X equals negative 20 plus or minus the square root of 628 all over 2. Now, I don't think 628 is a perfect square. Just double check it. No. Okay, so let's leave it in radical form. Great, you're going to see an example of that. So there is nothing else I'm going to do at the moment. So now I'm going to split into the two possible answers. X equals negative 20 plus root 628 over 2, or x equals negative 20 minus root 628 over 2. Here is where we want to see these values with the calculator. I'm not doing so much in my head now anymore. Let's open up the calculator. I'll pull that onto the screen. Okay. I'm going to use that fraction key. Remember for negatives to use your negative, not the subtraction. So negative 20 plus the square root of 628 over 2. Let's see, this calculator will display it in radical form, but let's just go to decimal. 2 2.5, let's say 2.53, okay? 2.53. And we'll take a look at the other one. We just need to put a subtraction in front of that radical sign. So I'll just enter it again to be on the safe side. Negative 20, subtract the square root of 628 over 2. Again, we get this radical form, and I'll just change to decimal, negative 22.53. Okay, so 2 possible answers. These are the 2 mathematical answers. They might not both make sense for what we've been asked, okay? Let's just go back to the question and see what we were asked. Find the value of x that when added to both dimensions, the area will be increased by 57 meters squared. So if I was to take my 8 meters by 12 meters and add 2.53, and I would get both positive values. However, if I add negative 22.53 to those, I am getting negative values, and negative values for dimensions will length and width kind of don't make sense. So looks to me like we've got our answer here. And if you want, you could add that value to 8 and 12, find the area, and you should have the 96 increased by 57. All right. Thanks for watching. That's it for now.